Hello everybody, my name is Pranishwar Reddy, studying in JNTH Mechanical second year, second semester, regular. So today we are going to learn about ELCB. So what does it mean? Earth Leakage Circuit Breaker. Okay. So Earth Leakage Circuit Breaker is a safety device used in electrical installations with high earth impedance to prevent shock. Okay. So earth impedance is basically a earthing system or a grounding system. So what does an ELCB does? It detects small stray voltages on the metal enclosures of electrical equipment and interrupts the circuit if a dangerous voltage is detected. Okay, so if sufficient voltage appears across the ELCB sense coil, it does have a coil, so it will switch off the power and remain off until manually reset. Okay, so the main purpose of using this ELCB is to prevent injury to humans and animals due to electric shock, and it also protects the electrical appliances. Okay, so now let us see the types of ELCBs. Okay, there are basically two types of ELCBs. First one is a voltage operated ELCB, and the second one is current operated ELCB. Current operated ELCB is also known as RCCB, that is a residual current circuit breaker. So let us see now a voltage operated ELCB. Okay, so if you see this line diagram here, see. So what happens is we have two conditions. First one is a normal condition, second one is an abnormal condition. So in the normal condition, what actually happens is the phase currents flowing to the load from the circuit breaker will be equal to the currents flowing back to the neutral. That is IN equal to IR plus IY plus IB. So as you can see here, IN equal to IR plus IY plus IB. So, but as in case of the abnormal conditions, what happens is it is abnormal because of some faulty currents or some leakages present at the load. So if you see here in the line diagram, the current flowing from the phase at the load, what actually happens is some leakage of the current occurs, and this leakage is detected by the relay, and it sends signal to the circuit breaker, and thus the switch is off. After crossing a predetermined value, this the circuit is off, like cut off, or the switch is off. Okay, so and also the leakage will be sent is earthed, and it will be sent to the ground. Okay. Now let us see how does an current operated ELCB works. Okay, so it does also have two conditions. First one is a normal condition, second one is an abnormal condition. Okay, in the normal condition, if you see here in this like line diagram of current operated ELCB or RCCB, what happens is, see, if you see here, we are considering a single phase circuit, and the current flows from the phase to the right side winding, that is solenoid, a copper winding, and then to the load, phase of the load, and neutral of the load to the neutral of the source from the left side winding. So now let us assume 10 amps of current is flowing through the right side winding, and due to the Faraday's law of induction, what happens is the due to the electric field due to the electric field, there also will be generated an magnetic field around this coil, or around the conductor. That from the Faraday law of induction, we can state that. So what happens is the magnetic flux generated here in the right side winding and in the left side winding will be balanced and cancelled out. Therefore, net magnetic field will be equal to zero. And as in case of abnormal condition, what actually happens is due to some leakage in the current, due to the leakage in the current, the uh, excess amount of current or the leaked current will be sent to the relay. Here you can see the relay, the diagram. So these relay have a solenoid or a coil. So basically here also from the Faraday law of induction, there will be some magnetic field generated, and it attracts the plunger towards it. Plunger is basically a metal. So the metal is attracted towards this magnetic field. So thus the tripping happens, the tripping of switch happens. See, you see this dotted line connecting the plunger and the switch. So thus, by the help of the plunger, tripping happens and the switch is off. Okay, so when the residual current exceeds a fixed value, as I mentioned before, so this ELCB cuts off the power within the time of 0.1 seconds. So automatically it is protecting the personal safety and preventing the equipment from the fault. So this is the working of the RCCB. Now let us see the advantages and disadvantages of ELCB. So these are less sensitive to fault conditions. So they can detect like minute fault conditions also about this fixed value. So they can be arranged to protect cable damage only. And the disadvantages of ELCB are they do not detect the faults that don't pass through the CPC to the earth rod. So what does CPC mean? Circuit protective conductor. So it does not detect the faults which does not pass through this CPC. Okay, that is a disadvantage. And ELCBs introduce additional resistance and an additional point of failure into the earthing system. So it gives an additional resistance. ELCBs gives an additional resistance so that it is not used like most of the newly manufactured electric appliances are not used of ELCBs, and they are using RCCBs as a circuit breakers. So that's it. If you can also see this image on the right, when it is earth, when the case is not earth, you can see it is not unsafe and can cause some electric shock. And when it is earth, it is safe and you can also touch it. Like there will be some protection available there. So that's it. Thank you.